Dear students, have you ever tried measuring the length of a pole? Sounds quite easy, isn't it? We can be doing it by using a scale. However, have you tried measuring the diameter of a wire? Sounds difficult, right? But we can make it easy for you by introducing an instrument called screw gauge. This is an instrument which helps us measure such small objects. Now, let us take a piece of paper and measure its length. Which device do we use to measure the length of an object? Scale or a measuring tape? Look at the scale. What is the measure of each division? Centimeter. Now, take this scale and measure the length of the paper. What is the measure? A little more than 15 centimeters. The scale we have taken has only divisions of centimeter, so the length of the paper, 15 centimeters, is not an exact measure. Now take the scale with millimeter divisions on it. Find the measure using this. How much is that? 15.1 centimeters. By minimizing the scale from centimeters to millimeters, we have given the precise measure up to 1 millimeter. Let us magnify the portion between 15.1 centimeters and 15.2 centimeters and observe. The paper is in between the two measures. That means 15.1 centimeter measured using the millimeter scale is also not accurate. For this, we have to divide the millimeter again into smaller divisions. As you have already learnt in the previous class, vernier calipers helps us divide millimeter into even smaller divisions accurately up to 0.1 millimeters. If we want to measure the length of an object up to 100 parts of a millimeter, is it possible for us to measure with an ordinary scale or vernier calipers? No, it is not possible, since the least count in an ordinary scale is 1 millimeter and the least count in a vernier calipers is 0.1 millimeters. So we can use another device called screw gauge, which can measure accurately up to 0.01 millimeters. Let us proceed further to know more about the screw gauge. Screw gauge is the mechanical device commonly used in laboratories to measure the thickness of a plate or to measure the diameter of a wire accurately, which is not possible by an ordinary scale. Then, what makes it special? So, how can we measure accurately? To answer these questions, we should know its working principle. Screw gauge works on the principle of a screw in a nut. So, we call it screw gauge. It is also called a micrometer screw gauge. Usually, a screw refers to the metallic shaft upon which a spiral thread is finely cut along its length with a head on one end and a tip at the other end. Separation between the adjacent threads will be the same all through the length. If the head is rotated, the shaft moves through the fixed nut which has a similar thread cut inside it. Rotate the head of the screw through one complete rotation. It moves through a distance equal to the separation between two adjacent threads, and this distance is measured parallel to the axis of the screw and called the pitch of the screw. Hence, pitch of the screw is defined as the distance travelled by the tip of a screw for one complete rotation of its head. Pitch of the screw is determined by making a certain number of rotations of the head and noting down the distance through which the tip moves. Hence, pitch of the screw is equal to distance travelled by the screw divided by number of complete rotations made. If x is the distance travelled by the tip of the screw through a nut and n is the number of complete rotations made by the head, then pitch of the screw P is equal to x by n. What happens if we rotate the head through less than one rotation? Obviously, the screw will travel through a distance less than p, that is, a fraction of the pitch of the screw. What will be the smallest distance that can be measured by the least fractional rotation of the head? This value depends on how small a fractional rotation is, say 1 by 100 or 1 by 50 of a complete rotation we can make. For this, let us consider that the head of the screw is divided into n equal divisions. This is called the head scale. When this head scale is rotated, it crosses the index line drawn parallel to the axis of the screw, which has some convenient divisions tapped on it, and it is called pitch scale. As we have seen that when all n divisions on the head scale cross an index line, the tip moves through a distance equal to the pitch of the screw P. One complete rotation of the head makes it to travel on the index line through one division, which is nothing but P itself. When the head is rotated so that only one division of it crosses the index line, it moves along this index line through the smallest distance called least count. Therefore, least count of a screw gauge is defined by least count LC is equal to pitch of the screw by number of head scale divisions, which is equal to P by N, which is the principle of a screw gauge. Let us assume that the number of divisions on the head scale N is equal to 100 and pitch of the screw P is equal to 1 mm. Then the least count LC is equal to 1 mm by 100, which is equal to 0.01 mm, which is equal to 0.001 centimeters. This means that with the help of the screw gauge, we can measure accurately up to 0.001 centimeters. Now, let us see how a screw gauge looks like. It has a U-shaped metallic frame F. To one end of this frame, a flat stud S1 is fixed, and to the other end, a hollow long cylinder C is fixed. The hollow cylinder serves as the nut as it has fine threads cut inside. On the outer surface of this hollow cylinder, a line parallel to its axis called index line is drawn and is divided into some equal divisions, 1 mm or 0.5 mm. This is the pitch scale P. A screw with a flat stud S2 having threads exactly identical to the threads cut inside the cylinder moves through the cylinder C. Another hollow cylinder B acts as a jacket to the first hollow cylinder C. One end of this B is connected to the milled head M. The other end is tapered with some equal divisions up to 100 or 50. This scale is called the head scale H. Rotate the milled head to make the two studs S1 and S2 in contact with each other and are exactly opposite to each other. Then the edge of the head scale must coincide with the 0th division of the pitch scale, and also the index line is coinciding with the 0 of the head scale. Then we can use our screw gauge for measuring. The object that has to be measured must be placed between the studs S1 and S2 and rotate the milled head M until the position of the object is secured. Then the readings on both pitch scale and head scale has to be noted down. Before taking the readings using a screw gauge, we must first determine its least count. Let us rotate the head through some complete rotations and take it as N. Find the position of the edge of the head scale on the index line. This division on the pitch scale just preceding the edge of the head is the distance travelled by the screw X. The ratio of these gives the pitch of the screw, that is P is equal to x by n. Find the number of divisions on the head scale. Let it be capital N, the least count, which is equal to pitch of the screw by number of head scale divisions, which is equal to P by N. After finding the least count, place the object between the shafts S1 and S2 and rotate the head scale so that the shafts hold the object tightly. Observe the value of the pitch scale division which just precedes the edge of the head scale. This is the pitch scale reading PSR, and find the head scale division that just coincides with the index line. This gives the observed head scale reading HSR. Now the length of the object is found using the formula D is equal to PSR plus HSR multiplied by LC. One thing we must remember is when we are taking the readings for PSR and LC, they must have same units. Though the value we have found using the screw gauge may be accurate to 0.01 millimeters, but there can be an error which needs to be taken care of. The error here is because of the device. As we have seen it earlier, before taking the reading, we should check whether the two studs S1 and S2 are in contact or not. The zero of the head scale is coinciding with the index line or not. If they coincide with each other as shown in the picture, then there is no zero error. That is, there is no error in the device. If they do not coincide, then there is said to be a zero error. Let us see the different types of errors that arise due to mismatch between zero of head scale and the index line. There are two types of zero errors. There are negative zero error and the positive zero error. These are defined depending on whether the zero of the head scale is below or above the index line. If there is an error, the HSR measured should be corrected after determining the zero error. Now, let us see how to identify these errors. If the zeroth division of the head scale is above the index line as shown here, then error is said to be negative zero error. To correct this error, let n be the number of head scale divisions that coincides with the index line. This value was not included in our observed head scale reading. Hence, it should be added to the observed head scale reading, which gives the corrected head scale reading. So, if the zero error is negative, then the correction has to be positive. Then, corrected head scale reading CHSR is equal to observed HSR plus n. If we observe the reverse, that is, the zeroth division of the head scale is below the index line, then the error is called positive zero error. To correct this error, observe the number of the head scale division that coincides with the index line. Let it be n. Hence, it should be subtracted from the observed head scale reading to get the corrected head scale reading. Therefore, if the zero error is positive, then the correction has to be negative. Then, corrected head scale reading CHSR is equal to observed HSR minus n. After finding the type of zero error, the correct reading using the screw gauge can be determined applying the formula D is equal to PSR plus observed HSR plus or minus n multiplied by LC, where plus sign is to be used for negative error and minus sign is to be used for positive error. Thus, finally, D is equal to PSR plus CHSR multiplied by LC. But these errors can be easily eliminated. Just what we have to do is to adjust the position of the stud S1 by rotating the screw behind it. Thus, thickness of a glass plate, diameter of a small lead shot, or that of a wire can be determined by similar procedure. As an example, let us take a lead shot and measure its diameter using a screw gauge. As learnt before, first we should find the least count. The screw gauge we are using here has 100 divisions on the head scale, that is, n is equal to 100. For one rotation, the screw covers the distance of 1 millimeter. Hence, the pitch of the screw is equal to x by n, which is equal to 1 by 1, and the answer is 1. Least count is equal to 1 by 100, which is equal to 0.01 millimeters. Now, let us see whether there is any zero error or not in the device. Rotate the head so that the two studs are in just contact with each other. In the present case, the 0th division of the head scale is 5 divisions below the index line. So, there is positive error and the correction is negative, that is -5. Now, place the object between studs and rotate the head till the object was held tightly between the studs. For pitch scale reading PSR, observe the last gradation visible to the left of the head scale, which is 6 millimeters. So, PSR is equal to 6 millimeters. For head scale reading HSR, observe the head scale division that coincides with the index line. Here, that is 21. So, HSR is equal to 21. Corrected head scale reading CHSR for positive error is equal to observed HSR minus n, which is equal to 21 minus 5, which is equal to 16. Diameter of the lead shot D is equal to PSR plus CHSR multiplied by LC, which is equal to 6 plus 16 into 0.01, and the answer is 6.16 millimeters.